Welcome on board. A viewer of my videos asked for an ILS tutorial, so I thought, why not? Let's make a summary of what I know about the subject and give a general idea of its working and the systems around it. The video has two parts. First, I show what we need as a minimum, and then I go into more detail. Although I did my best to give correct information, it will not be complete. All that I explain is for use in a simulator. For this flight, what better airplane could I use than the A2A Simulations Cessna 172 trainer? An ILS approach is called a precision approach because it has horizontal and vertical guidance to the runway. Horizontal is the course from the localizer, vertical is the glide slope to the runway at approximately 3 degrees above ground level. It can be more or less if there are obstacles, for example. In all the flights in this video, I land on Monterey, runway 10 right. For ILS we need two values, the ILS localizer frequency and the course heading. We can find this in the flight plan map. When we show the localizer feather and put the mouse cursor over it. In the map behind the location button, you can also find it in the menu World Map. Also on the internet or in a flight plan program like Plan G. The more correct way is to use the official approach chart. I'm going to land at Monterey, runway 10 right. The localizer frequency is 110.7 and the approach course is 98 degrees. Let's fill this data into the cockpit instruments. In the nav1 radio I set 110.7 and set it to the active frequency. With the OBS knob under the VOR1 gauge I set the approach course to 98 degrees. If a GPS nav switch is present, set it to nav. Sometimes it is built into the GPS system and you have to press the CDI button to do the same thing. In a lot of ILS approaches, you also have a DME, distance measuring equipment. With your DME equipment, you can then get the distance to the DME that mostly is located at the localizer itself. Here we are already in range of the DME signal. We're at 13.1 nautical miles from it. When we are in range of the localizer and the glide slope, the two needles in the VOR1 gauge will indicate our position in relation to the course and the glide slope. The middle point represents the airplane. Here the course is to the right, so we fly too much to the left. Here the glide slope is above us. We need to climb to intercept it or continue to fly at this altitude until we cross the glide slope. Here the glide slope is below, so we need to descend to intercept it. Lighter general aviation airplanes are sometimes flown a little above the glide slope. Otherwise they need to fly a power-on approach, with more power for the same airspeed. And in case of an engine failure, you are better at a higher altitude. I'm going to give a quick example in the cockpit. The localizer course is a little to our right. Because I'm flying a bit more to the right than the 98 degrees course, I will intercept it. If you fly it manually, set the heading bug to the course heading and use it as a reference. The autopilot is in heading mode and I alter the heading bug to intercept the course. I'm on the course and the glide slope. The two needles are in the middle. Now I need to start descending and follow the 3 degrees descent to the runway. If the airplane has an HSI, a horizontal situation indicator, it has NAV1 built into it. A vertical course deviation bar and two glide slope pointers, one on the left and one on the right. When the course is intercepted, I need to fly at the localizer course 98 degrees. Because I turned a little too late, the course will go to the left and I need to fly more to the left to intercept it again. Because I'm flying level, I'm going to intercept the glide slope. Once I'm on the glide slope, I need to start the descent and keep the glide slope pointer in the middle to fly the 3 degrees descent. I have drawn a chart to explain the ILS system. ILS stands for Instrument Landing System. Its only purpose is for landing guidance, not positional like NDB or VOR. The localizer antenna array is at the end of the runway and transmits the course straight out. It can normally be intercepted from 18 nautical miles. The glide slope transmitter is located somewhere after the beginning of the runway threshold and sends the glide path signal that can normally be intercepted from 10 nautical miles. On the ILS course, there are a maximum of 3 marker beacons: outer, middle and the inner marker. Sometimes there are no inner or middle markers. The inner marker is mostly used with the more precise ILS approaches for category 2 and 3, where the decision height is much lower. These markers are sometimes used in the approach plates as a reference point and also give precise position reference points for the pilot. If you fly over the outer marker, a blue light with the letter O in it will illuminate, an amber light with the letter M when flying over the middle marker, and a white light with the letter I over the inner marker. It is also possible to hear a tone. I put the approximate distances from the markers to the runway threshold at the bottom. The final approach fix, FAF, is mostly marked with a cross. It identifies the beginning of the final approach segment towards the runway. It can be at the same location as the outer marker or not. Mostly the airplane is set to the landing configuration before crossing the FAF point. The FAF and the outer marker can be used to check if the altimeter is working correctly by checking the expected altitude when flying over it. The lowest altitude an airplane can descend without having the runway in sight on a precision approach is called the decision height. On a non-precision approach, this point is called the missed approach point. It is mostly equal to or around the middle marker or the inner marker. On a precision approach, the glide slope intercept altitude point is mostly indicated by a lightning bolt symbol. That's the point where you must have intercepted the glide slope and start the descent. It's located at or near the outer marker, or the final fix. On most runways, with an ILS approach, you will find PAPI or other lights that give a visual aid for an approximately 3 degrees glide slope. It stands for Precision Approach Path Indicator. In the system with 4 lights, when you see 2 white and 2 red lights, you are on the glide slope. The more white lights you see, the more you are above it. The more red lights, the lower you are. You can see red as the ground and white as an overcast sky. Sometimes the outer or middle marker or the final approach fix point have an NDB, a non-directional beacon. It is then called the locator outer marker, written as LOM, and the locator middle marker, LMM. On some approaches, you can intercept the LOM or the FAF point from any or different directions and can use an ADF radio to intercept it. Then intercept the localizer course for the final approach. In this flight, after takeoff, I fly directly to Shui Point at 2500 feet, then turn left to 113 degrees, descend to 1700 feet and intercept the glide slope at the glide slope intercept point to start the descent to the runway. The final approach fix point is at 5.6 nautical miles from the DME. The outer marker is at the same point. The decision height is 480 feet for the ILS approach. If the runway isn't in sight at decision height, the missed approach procedure is started. The glide slope is 3 degrees. There is a visual descent point indicated with a V, normally for non-precision approaches, and an indication that the ILS is unusable from 1.8 nautical miles from the DME. The outer marker is a locator outer marker. It has an NDB with the frequency 385. I'm not going to use it. I set the GPS nav button to GPS because I'm first going to use the GPS to fly to the Shui point, the first waypoint. I use the Direct To button to set the first waypoint Shui. The course to this waypoint is 267 degrees. I can also find it on the left top side of the screen and in the flight plan. I set the OBS knob to 267 degrees, so I will be able to see my position relative to this course on this gauge. With the switch to GPS, the VOR1 gauge will show my position relative to the GPS course, represented by the purple line on the GPS screen. I set the minimum altitude to cross the Shui point, 2500 feet, in the Autopilot. With this autopilot, set the barometric pressure also with the baro button, or it will not necessarily level off at the correct altitude. The weather is ideal for an IFR flight. I'm almost at the waypoint Shui. I set the autopilot in heading mode, so it will follow the heading bug. At the Shui point, I start turning left to 113 degrees. With the autopilot in heading mode, I turn the heading knob. As a reference, I activate the ILS approach on the GPS. I can continue flying in this direction until I will almost cross the localizer course. I set the GPS nav knob to nav for the VOR1 gauge to show my position relative to the localizer and the glide slope. The localizer course is to my right. The GPS confirms this. and we are flying below the glide slope. I start turning to the left, so when I cross the course, I will be at 98 degrees. I've intercepted the localizer course and I'm flying at 98 degrees. I'm flying level. I will shortly intercept the glide slope. The needle starts descending faster. The closer we will fly to the runway, the more sensitive the two needles will be. We have intercepted the glide slope and are at 1700 feet altitude. This is the glide slope intercept point from the approach chart. We are at 5.8 nautical miles from the DME. A little before crossing the glide slope, we can start descending. The target vertical speed is approximately your speed times 5 to keep the 3 degrees glide slope descent. We're over the outer marker at 5.6 nautical miles. The blue O light is on. This is also the final approach fix. The altimeter has the correct altitude of 1600 feet. No correction is needed. The course is to the right and the glide slope below us. I need to turn to the right and descend more. We're above the middle marker. Inner marker. Once I cross the glide slope transmitter, the horizontal needle stops working. The puppy lights are to the right of this antenna. The localizer at the end of the runway is still intercepted. It's at 0.9 nautical miles. The more I go away from the center line, the more the needle is moving.